Let's do some more examples of scientific notation. Now, in this example, I want to change this number to scientific notation. So let's change 1.753 to scientific notation. So first I need to find the original decimal, which is right here after the 1. And to follow the 3 steps, I'm going to start by putting my new decimal after the first non-zero digit, which means it's going to be right here in the same place. In step 2, I count the spaces between the original decimal point and the new decimal. And since they're in the same place, there are no spots between those decimals, so I have 0 spots. In step 3, I'm going to write my new number with my new decimal, 1.753 times 10, because it's always times 10 to an exponent. But in this case, the exponent is going to be 0, because there are no spots between the original decimal and the new one. And since we didn't move the decimal right or left, there's also no sign. So the answer in scientific notation is 1.753 times 10 to the power of 0. Here's another example. Let's convert 237.5 to scientific notation form. My original decimal here is after the 7. Now in step 1, I'm going to write a new decimal after the first non-zero digit, which is the 2. So I'm going to put a decimal right here. In step 2, I'm going to count the number of places between the original decimal point and the new one. So 1, 2. So I'm just going to make a little note that there are 2 so I don't forget. And notice that I moved from right to left. So in step 3, I'm going to write the new number with the new decimal, 2.375 times 10, because it's always 10 to an exponent. And we moved it 2 places, so it's going to be an exponent of 2. And I moved 2 places to the left, so it's going to be to the power of positive 2. For the next example, let's change this very small number, 0.000000035, to scientific notation. We find the original decimal point, which is right here, but now we're going to show our new decimal right after the first non-zero digit, which is the 3, so it'll be 3.5. Now we're going to count the number of places between the decimals, 1, 2, 3, 4, 5, 6, 7. There are 7 spots. So in scientific notation, it's going to be 3.5 times 10, because it's always 10 to an exponent, and the power is 7 because we moved 7 spots. But notice that this time we moved from left to right, so it's times 10 to the power of negative 7.